Hello everyone. This video is about integrals. In this chapter, we have two types of integrals: indefinite integral and definite integral. This video is about indefinite integral. By integral, we mean antiderivative. By antiderivative, we mean the inverse of derivative. In this lesson, we will be going backwards. We will be finding the function, the original function, when the derivative function is given. Let's talk about some notations for antiderivative. Capital letter F is called antiderivative, and we write the antiderivative as by using this symbol. The long as looking symbol represents integral. So this long as looking symbol of f of x, a little f of x dx, is equal to the antiderivative. So we always have this as looking symbol with dx. They are together inseparable. It also means this little f is represented by f prime, the uh, uppercase letter f prime. This is the same. So we put the derivative inside the integral symbol, and the function that we have before taking derivative outside of this symbol. Let's take a look at this. This is called integrand. Whatever we have inside the integral symbol is called integral. This dx is the variable of integration. Other side of the equation, what we found after taking the integration, is called antiderivative. And we always add c after finding the antiderivative, because let's take a look at this example. Let's say I know what little f is. I know what the function should be written inside integral is as 2x. I'm looking for its antiderivative, meaning this little f is a derivative of something. Like here, this inside is derivative of something, but this 2x is derivative of what? You can do some mental math and say it's x squared, right? Derivative of x squared is 2x. So x squared is not the only possibility. We may have something added to the x squared or subtracted from x squared, right? We can say x squared plus 1's derivative is also 2x. X squared minus 2's derivative is also 2x. So we have many, many antiderivatives, right? It varies from function to function. We have different constants for each antiderivative. So to generalize this antiderivative, we write the antiderivative as not just x squared plus c, since we don't know what c is. Okay, so when we write this by using integral, we are going to use this as looking symbol with the function given, the derivative. This is the derivative. This represents whatever we are writing inside the integral symbol is derivative. Dx is equal to the antiderivative, the function before taking derivative. What was the function before taking derivative of 2x? It was x squared. Since the constant can be anything, because taking derivative of any constant results in 0, we have to add c. All right. It may seem complicated to you at first, but when you learn about the integration rules, it will be very easy, because you have studied differentiation rules. It is similar to the differentiation rules. We will be doing exactly the opposite things by using different integration rules. In derivative, okay, let's talk about the rules one by one. Basic integration rules. First rule, integral of 0 dx is c, constant. You can go in the other way around. You can say derivative of c is equal to 0. Okay, the second rule, integral of k dx is kx plus c. You can go the other way around. Whose derivative is k? Derivative of kx is k. Let's take a look at this example. Integral of 2dx. Whose derivative is 2? Derivative of 2x is 2. We write plus c always. Another rule, the power inverse power rule. In derivative, if there is a power, we bring the power down in front and decrease the power by 1. Here, since it's the inverse, we will be doing the opposite. Instead of decreasing the power by 1, we will increase the power by 1. Let's increase n by 1. It's going to be n plus 1. Instead of writing the old power in front, we're going to write the new power at the bottom. So integral of this is x to the power of n plus 1 over n plus 1 plus c always. And there is a little note here, and the exponent is not -1. If it is -1, we have another rule. Okay, this is for exponents whose exponent is other than -1. Let's take a look at this example. X cubed. Let's apply the rule. We increase the power by 1, 3 plus 1, and divided by the new power, plus c, which will give me x to the power of 4 over 4 plus c. Okay, this is the way, exactly the opposite idea of derivative. There are some questions that require simplifying at first, rewriting at first. So for such questions, just like in derivative, we rewrite the given function first, simplify it as much as possible, and integrate it. After integration, we are going to rewrite it again. Okay, first simplify and last simplify. All right, so we will be doing simplification, the rewriting 2 times, before integration, after integration. So this question, we know the power here for square root is half, and we also know that we have the same bases. Then we keep the base and add the exponents, 1 plus 1 over 2, 3 over 2, and we got it in simplest form. We rewrote this in simplest form. Now it's time to take integral. So when we take integral, apply the rule, increase the power by 1, x plus 3 over 2 plus 1, divided by the same power. What is 3 over 2 plus 1? This is 1.5 plus 1, 2.5, which means 5 over 2. X to the 5 over 2 over 5 over 2. I don't want fraction at the bottom, so let's flip it then. 2 over 5, x to the 5 over 2. Remember, in derivative questions, we never left questions with rational exponents. We changed this into radical expressions. So let's write this as radical. 2 over 5, x to the 5 under square root. I can simplify this more, get rid of the even powers, the perfect square powers, which is 2 over 5 x squared x plus c. Always, I had plus c's here too, of course. Okay, this is my final answer. If you are not sure about your answer, you can take the derivative of the result, see if it gives you whatever you have inside integral symbol. Exercise 5. Same idea, I have to rewrite this first. Integral 1 over x, just like this, it is x to the 5 over 2 dx. Just like in derivative, we may not have variables at the bottom. In order to apply this power rule, we have to move it up. Let's move it up. X to the -5 over 2 dx. Now, we are done with rewriting this. So it's not 5 over 2, it's 3 over 2. Okay, now we are done with rewriting the original function, original question. We are going to take its integration. Let me use another color. Okay, now increase the power by 1. Negative 3 over 2 plus 1 over negative 3 over 2 plus 1 plus c, of course, equals x to the negative 3 over 2 plus 1 is negative 1 over 2 over negative 1 over 2. Let's get rid of this fraction from the bottom by flipping this negative 2 in front plus c. Let's get rid of this negative exponent by moving the variable down. 2 x to the, there's negative 2 x to the half, and let's convert this rational exponent to radical. So that's my answer. Take derivative of this, you'll get that thing. Okay, so these are the similar questions in the book. Constant multiple property. Like in the derivative, we can take this constant in and out. Okay, we can move this out in front of the integral. Let's take a look at this exercise and a ministry question. We rewrite the question first. It is 1 over 3 squared is 9. X squared is x squared dx. I have a coefficient in front, which is 1 over 9. I can pull this out in front. So let's write this as 1 over 9 integral 1 over x squared dx. I have variable at the bottom, which is not possible to solve by using power rule, so I should move it up. So it is 1 over 9 in integral x to the power negative 2 dx. So 1 over 9, let's increase the power by 1, x to the negative 2 plus 1 over negative 2 plus 1 plus c. Okay, now we have 1 over 9, x to the negative 1 over negative 1 plus c, which is 1 over 9. Since there is negative power to move, to make it positive, move it down again, x, and I had negative. I want to put this up. Doesn't matter where you put it, either in the numerator or denominator or in front. Plus c, of course. All right. So we are done with fourth property. Now let's continue with this fifth one. The addition or adding or subtracting two functions inside the integral is same as adding and subtracting the integrals with the same functions. We can break this up into two pieces if it is necessary. If it is not necessary, we don't need to do that. There will be questions that it is necessary in the second section. Here, however you feel comfortable, you can break it up into two, or you can just solve them under the same integral. It's up to you for this section. We will be doing this, using this in the second section. So here, I don't want to do this. It is not necessary here. But to show you, I can do it for one question. Let's break this up into two. Write this as, there are two terms. Integral of 2x dx minus integral of 3x squared dx. Now, take integral of each. Integral of 2, you can take 2 out first and increase the power by 1. The power was 1, it becomes 2 over 2 minus, take the coefficient out in front, increase the power by 1, 2 became 3 over 3 plus c. Now, 2's cancel each other, 3's cancel each other. The answer is x squared minus x cubed plus 3 plus c. Okay, so sum or difference of the integral of sum or the difference of two functions is same as sum or difference of the integrals with the same functions. This is the property. This will check it out one. Let's do one more question about this property. Partial test 1c. It's such a complicated looking question, So we should simplify it first to make it easier. So we have square here. Let's expand this. Square of the first one, which is x, minus 2 times first one times second one, plus square of the second one, over square root of x dx. Now, I can either do this like in the previous question, separate the integrals, separate each term one by one, or I can do this under the same integral. Let me do this with the same integral under the same integral symbol. Since it's fraction with three terms at the top with the common denominator, I can use the common denominator, break this up into three pieces. There are three terms at the top. I can break this up into three pieces. So first piece, x divided by square root of x, minus second piece, 2 square root of x over square root of x, plus third piece, 1 over square root of x dx. Now simplify, we keep simplifying. Here I have the power 1, here I have power half, right? Minus square root axis will go, plus 1 over, here I have power 1 over 2. I am not done simplifying. I have the same basis with different powers. Subtract power since it is division. It's 1 over 2. 2 stays. I move variable up. Dx. Now I am done with simplifying, rewriting the original, the given function. Now it's time to take the integral. So integral of the first term, increase the power by 1, minus integral of the second term, just add x. Integral of the third term, 1 over 2 plus 1 over 1 over 2 plus 1 plus c. Now, 1 over 2 plus 1 is 3 over 2 over 3 over 2 minus 2x plus x to the power of, this is negative, sorry, 1 over 2 over 1 over 2 plus c. Okay. Now, let's get rid of these fractional denominators. Flip it. 2 over 3x to the 3 over 2 minus 2x plus 2x to the half. Now, let's convert these fractional exponents to radical. 2 over 3 x cubed under square root minus 2x plus 2, 1 over 2 represents, the power 1 over 2 represents square root of x. We can simplify x cubed more as x root of x. So 2 over 3 x root of x minus 2x plus 2 root of x plus c. Okay, this complicated looking question's answer became this. To make sure if you get the same correct answer, you can take derivative and see if it gives you this inside function. Okay, we are done with fifth property. Sixth property, exponential rules. For derivative, it was derivative of the exponent multiplied by the same function. Now, instead of multiplication, we have division as in the other rules. We take the derivative of the power, which is a. Instead of writing it as a coefficient in front, we write this as a coefficient at the bottom. Okay, not in front, at the bottom. Not multiplied by the derivative, divided by the derivative. Okay, this is integral. We divide the original function by its derivative, plus c, of course. So now let's take a look at this ministry question. 3a to the power of 3x divided by derivative of the exponent, which is 3, minus derivative of 1 is just add x. 3's cancel each other. A to the 3x minus x, of course, plus c will give you the integral. There is one more ministry question about this. Okay, another rule. We said in the third rule, if there is a power, then in order to apply the power rule, we should make sure that the power exponent can never be equal to 1. If it is 1, we have another rule. So this is the rule that we will apply when the power is equal to 1. What is this rule? Now, let's for a second consider derivative of ln. What is the derivative of ln? Derivative of ln is 1 over x, right? The power is 1. So integral of 1 over x will be then ln x, right? So integral of 1 over in a linear function, because linears have power 1 for x, the integral is ln of this thing written in the denominator divided by the derivative of the argument here, derivative of the denominator, in other words. Okay, so ln of the denominator divided by derivative of the denominator. All right, just opposite of the derivative. Plus c. We put the denominator in the absolute value to make sure that this is not negative, because according to the definition of natural logarithms, the argument should never be negative or 0. It should be always positive. Let's take a look at this example. According to this rule, it is we keep the coefficient in front too. Write ln, write the denominator 3x plus 1. In the denominator, we are going to write the derivative of denominator, which is 3. Okay, it's that simple. There is no exercise, no ministry question about this situation, but the rule stays. Okay, finally, let's take a look at trigonometric functions integration. Now, think about the function whose derivative is sine x. Which function's derivative is sine x? Derivative of cosine is negative sine x, so I should have a negative in the integration. Derivative of sine is negative cosine of the same angle. Instead of multiplying, we are going to divide it by the derivative of the angle. When we take derivative, remember, we were multiplying the function by derivative of the angle. Now we are dividing the function by the derivative of the angle. Okay, plus c. For cosine, whose derivative is cosine? Derivative of sine is cosine, right? So integral of cosine is sine of the same angle divided by the derivative of the same angle, plus c. About tangent, derivative of tangent is either 1 over tan squared or 1 over cos squared. So integral of either 1 over tan squared or 1 over cos squared gives you tangent plus c. Okay, so exactly the same rules came in Wazari, and it's an exercise question. Okay, let's finish this lesson with these two questions. 2 sine x, its integral is 2 stays. Integral of sine is negative cosine. Put negative in front. Since the angle is just x, we don't divide it by 1. We just leave it. Plus 3 is the coefficient stays. Derivative of integral of cosine is sine. Sine x plus c. Lastly, study guide 4. Integral of cosine is sine. 5 sine x. Minus 2 is the coefficient. Integral of 1 over cosine squared is tangent. Plus c. So I'm done explaining the rules of integration. So we solved questions about every rule. We are done with antiderivative thing.